Okay, so in this chapter, chapter 12, we're going to study transformations. And a transformation is a change. Okay, so I think you already studied transformations when you were in 8th grade, right? Okay, so what are the transformations that you studied when you were in at least 8th grade? Reflection is one.
Translation.
Translation. We have lines of reflection, or right? But the transformations are reflections, translations. What else?
Rotations.
Rotations. And we're missing one more. The flip is a reflection. So reflection, translation, rotation. And we're missing one. That is not an isometry, because they're listing the isometries here. Which is that one? Okay, let me give you a little hint. When you go to the eye doctor performs this transformation. Obviously on your eye, on your pupil. They put some drops, orange drops. What happens? Why do they do that? Dilating, that is right.
Don't they just like cover your eyes and then make you read louder?
Doctors, when they want to see more in depth, like, yes, you get to see all blurry because your pupils are dilated, because they want to enlarge that pupil so that they can see that, the inside of the eye better. Right, completely open. Right. So that is a dilation, okay? So dilation is a fourth transformation that is not listed here. See, notice that here it says an isometry is a transformation that does not change the shape or size of the figure. And reflection is an isometry, a translation is an isometry, a rotation is an isometry. But the one that is not an isometry is dilation. How come dilation is not an isometry? Does it change the shape?
No.
No, the shape is the same. What does it change? The size. On dilations, you change the size. It could either enlarge or you can reduce it. Okay? So that's why that's not an isometry. A reflection is a transformation, and like Jimmy, you were saying that, right?
Yes.
You said, which is the one that is a flip? Well, the flip is this one. That flips a figure across a line. And then, Derek, you said the line, the symmetry line, right? So the symmetry line is this one, and it flips, which means that in this case it flipped this way. So this is not a reflection. This is more like a what? A rotation, right? It's a rotation. It's rotating. This is rotating this way. Yes. Okay, it's more. It could be a rotation, but not really, right? It could be,
Yes,
but
you
not.
could go to the right, clockwise.
Clockwise. What about if you just flip it this way? Right? So, yes, so it's a reflection probably like this at this line of symmetry. So it's a reflection like this, and then a reflection this way. So this is a two reflection, right? Object. You reflect it over this line, coming this way, and then you reflect it over this line, coming this way. So that we're going to study later on in section 12 I think it's 12.4, when you have composite transformations, when you have two more transformations going on. But this is not a reflection. So now, for problem on the example, at the bottom it says, the line of reflection is a perpendicular bisector of each segment joining each point and its image. So if you reflect point A, this is the original. By the way, A is the original, A prime is a transformation. B is the original, B prime is a transformation. C is the original, C prime. Prime means that little quotation mark on the top. That means prime. And the prime notation is used for transformations, okay? So if you measure from the line of symmetry to B, that should be the same thing as the line of symmetry to B prime. go ahead and measure from A to the line with the ruler. Everybody has a ruler, right? So go ahead and measure in centimeters. In centimeters, how many millimeters do you have there?
It's 1 centimeter.
Centimeters. Okay, so how many centimeters? 1 point what?
1. 1 centimeter.
It's more than 1 centimeter. Is 1 point what? From A to the line of symmetry.
Like 7.
That's right. So it's like 1.7 approximately. Now, from A to the line of symmetry,
It's 1.
1 what?
1 centimeter.
Ah, okay. Well, see, I'm using the one on the screen, so maybe you're right. On my okay, so 1. You're right. Yes, on that little paper is 1. On my screen is 1.7, but you're right, it's 1. So is it 1 unit from the line of symmetry to A prime?
Yes.
Yes. How about from C to the line of symmetry? Is that also 1? Yes. And to C prime, is that 1? Yes. Okay, so then the distance from the original point to the line of symmetry should be the same to from the line to the prime point, okay? And it has to be perpendicular. So in problem number 1, it says, tell whether each transformation appears to be a reflection. Is number 1 a reflection? No. How about number 2? Yeah, that one is. And then in number 3, we're gonna go ahead and do the reflection. And what I suggest that you do is get the patty paper on top of your paper, please. So get the patty paper on top of the paper. And then trace the line. So this is, if you use patty paper, you trace the line. And then you trace also the figure that is given. In this case is this quadrilateral, this parallelogram. And now flip the paper over the line. And it's hard for me to show you that because I don't have patty paper here. But when you flip it, you're going to have that figure on the left side. So when you flip it, you flip it and then you see the shape on the other side looking like this? So trace that. Trace it as you flip the paper. Trace it on the left. And that would be the reflection. So we're not going to use a ruler to get accurate measurements perpendicular to the line, stuff like that. We're just going to do simple as that, okay? And let's do the same thing with number 4. Get the patty paper, put it on top of the paper, then trace the line of reflection. So trace the line of reflection, and then trace that triangle shape. It's not really a triangle, but it's like a quadrilateral in a triangular shape. And then flip the patty paper over the line of symmetry. Then trace that figure. And what you should see is the shape reflected along that line. So that's all we're doing here. We're just reflecting whatever is on one side over the line of symmetry to the other side, okay? Any questions on how to determine if it's a reflection or how to get the reflection? No? Pretty easy, right? Okay, great. So, I don't want to move this. Now let's move on to the second page. Okay, you guys, so in this section, the reason why I need to make sure that I cover these 4 sections from chapter 12 with you guys is because when you get to algebra 2, when you get to pre-calculus, these transformations are going to be like the foundation that you need to have, so that way you know how to reflect, how to translate, how to rotate and stuff like that. Graphs that are going to be given to you in algebra 2, okay? They're going to give you a line and they're going to ask you to reflect it, to translate it, to rotate it, and you need to know what to do. So let's start with the first one, which is reflection. If you have a point, like for example here, the original point is x comma y. If you reflect it over the line x-axis right here, So what is changing? If I reflect it over the x-axis, it's coming this way. So what is changing? Does the x change, the x coordinate?
No.
No. What is supposed to be changing? The y coordinate. Because if it's like a 2 over the x-axis, this becomes a -2. Okay? Now, if it's a -4 and you reflect it over the x-axis, that's going to be a what? +4. Okay? Now, what about on the y-axis? Well, the y-axis is this right here. If a point is reflected over the y-axis, see here, this is the original, this is a prime because this is a prime notation. So if I have a point, the point is R. And if I reflect it over the y-axis, it's coming this way. So what is changing? The x. Okay, so just think about like the opposite letter. If you reflect it over the x-axis, the y coordinate changes. If you reflect it over the y-axis, the x coordinate changes. Okay. Now the third transformation that you need to be aware is when you reflect it across the line y equals x. Which is that line y equals x? Well, y equals x is the line in which you have a point, like for example, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. And the same thing to the left side. If x is -1, y is -1. So whatever the x is, the y is the same thing. So that is the line y is equal to x, okay? So whenever you reflect over the line y is equals to x, you are going to be changing what? What are you going to do? Look at the point. It was xy, and now it's yx. So what is the transformation? What's going on? You flip x and y. So whatever points they give you, just flip them around. And that's it. Okay? Okay. So let's go over the first problem. In problem number 1, it says, reflect the figure with the given vertices. First of all, let me plot the points. So I'm going to use one color for the original points. 2, 4. Put the point and then put the letter. Label it. N is for 2. Label the point N. P is 3, -2. And then connect those points with a ruler. Use a ruler, please. And now I need to reflect it over the y-axis. So on the side, I'm going to get my prime points. M prime. So if I reflect it over the y-axis, that y-axis is this right here. This is the y-axis. So what's going to change? If I reflect it over this line, this point has to reflect over here. This point has to reflect over here. So what should be changing? The x coordinate. When you reflect it over the y-axis, you switch the other letter sign. Okay? So the x is going to be changing. So if it was 2, 4, then that would be -2, 4. In point n prime, it would be what? -4, 2. And for p prime, that would be -3, -2. So the x changes the sign, okay? So, and then plot those points. -2, 4, and then label the point m prime. -4, 2, that would be n prime. And then p is -3, -2. That's p prime. And then we connect the points. Use a ruler to connect the points. And then you see the reflection over the y-axis, okay? Okay, so now go ahead and try problem number 6, please.